Dr. MGR Educational and Research Institute warmly welcomes you to its world-class educational campus that showcases excellent infrastructure facility housing various departments in diverse fields of study. Faculty of Engineering and Technology. IBM Lab, R&D Microsoft Lab, Sun Java Lab, .NET Lab, CDAC Garuda Lab, Internet Center, Apple iMac Lab, Cisco Net Academy, High Tech Lab, Cyber Forensic Lab, Intel Internet of Things Lab, Communication Lab 1, Electronic Circuits and Devices Lab, QMAX VLSI Testing Center, Linear Digital Integrated Circuits, Microwave and Optical Communication Lab, VLSI and Embedded Design DSP Lab, Microprocessor Lab, Electrical Machines Lab, Electrical Machines Lab 1 and 2. Smart Grid, Digital Design Lab, Electronic Circuits Lab, Digital Simulation Lab, Linear and Digital Integrated Circuits Lab, LDIC Lab, LabVIEW, Process Control Lab, Mechatronics Lab, Dynamic Lab, IC Engines Lab, Center of Excellence Multi-Fuel Engine Setup, Center of Excellence Biodiesel Plant, Metrology Lab, Metallurgy Lab, CAD Lab, CAM Lab CNC Lathe, CAM Lab CNC Milling Machine, Boiler Turbine Setup, Robotics Lab, Heat and Mass Transfer Lab, Welding Lab, Machine Shop Lab, Fluid Mechanics Lab, Manufacturing Technology Lab, Fluid Mechanics and Machinery Lab, Fluid Mechanics Lab, Survey Experiment, Survey Camp, Strength of Material Lab, Concrete Lab, Soil Mechanics Lab, Structural Lab, Environmental Lab, Transportation Lab, CAD Lab, Biochemistry Lab, Autoclave, Microbiology Lab, DBT Research Lab, Tissue Culture Lab, Genomics Lab, Bioprocess Lab, Instrumentation Lab, Molecular Biology Lab, Downstream Processing, Physics Lab, Chemistry Lab, English Communication Lab, Research Lab 1, Research Lab 2, Lecture Hall, Computer Lab, Animation Lab. Computer Graphics and Multimedia. Chroma Studio. Advanced Java Programming Lab. Software Testing Lab. Web Technology Lab. Lecture Hall. Architecture Studio 1. Architecture Studio 2. BARC Computer Lab. MARC Computer Lab. Photography Lab. Workshop BARC. Workshop MARC. Workshop CRIT Room. Material Museum. Faculty of Medicine. College Block. College Lobby. Classroom. Anatomy Dissection Hall. Anatomy Histology Lab. Anatomy Museum. Biochemistry Students Practical Hall. Physiology Hematology Lab. Clinical Physiology Lab. Physiology Amphibian Lab. Pathology Morbid Anatomy Histopathology Lab. Pathology Research Room. Clinical Pathology Lab. Pathology Museum. Pathology Demo Room. Pharmacology Experimental Lab. Dispensing Room. Student Practical Lab. Museum. Animal House. Microbiology Practical Hall. Museum. Research Lab. Community Medicine Laboratories. Community Medicine Museum. Forensic Medicine Museum. Forensic Medicine Laboratories. Cold Storage. Examination Hall. Hospital. OP Reception. ECG. Endoscopy Facility. Laparoscopy Facility. OBG OPD. Colposcopic Facilities. Labor Ward. Pediatric OPD. NICU. Opthal OPD. Opthal Operating Microscope. Surgery. CT scan. Full body X-ray. X-ray facilities. Mobile X-ray. USG. Ortho OPD. C-arm. ENT OPD. Audiometric facility. Psychiatry OPD. Dermatology OPD. Operation Theatre 1. Operation Theatre 2. Operation Theatre 3. Operation Theatre 4. Operation Theatre 5. Operation Theatre 6. Operation Theatre 7. Operation Theatre 8. Operation Theatre 9. Dental OPD, Casualty Minor OT, ICU, IP Lobby, Female Ward, Male Ward, Physiotherapy Department, 24 Hours Pharmacy, Central Laboratory, Blood Bank, Clinical Pathology Lab, Adayalampattu Urban Community Center, Parivakam Rural Community Center, Nazareth Pet Rural Community Center, CSSD, Laundry, MRD, Faculty of Dental Surgery, Oral Medicine and Radiology, Digital OPG, Intraoral X-ray, Skull X-ray, Department of Oral and Maxillofacial Surgery, Minor Operation Theatre, Department of Prosthodontics.
Welcome to the third day of our faculty development program on multidimensional scaling from science to technology, powered by Engineering and Technology first year in association with Office of International Relations. It's me, Dr. Lata. Happy morning to each and every one of you for being here with us today. Education is a passport to the future, for tomorrow belongs to those who prepare for it today. During the last 15 years, we in education have moved almost at the speed of light in the area of educational technology. Is obviously, students of this generation are highly accustomed to technologies. Yeah, they shine as a tech savvy. But we teachers should embolden ourselves as a digital, detailed oriented person, besides updating the knowledge in our own subject areas. With that in mind, today's session will be explored with one of the booming fields in computer technology, that's artificial intelligence, a buzzword, which is all around us in our daily lives. Yeah, every time when we open a Facebook news feed or do a Google search, or sometimes we get product recommendation from Amazon, and it's astonishing to see how the Google map works. Or how do an Uber determine the price for our destination? The answer to all these astonishing questions is artificial intelligence. That's AI, lurking at the background. Now, at this happiest moment, I would like to invite Professor Sona from Department of Mathematics to welcome the gathering. Ma'am, please.
Yes, ma'am. Am I audible, ma'am?
Yes, ma'am. Proceed.
Okay. Good morning, everybody. I am P. Sona, Assistant Professor, Department of Mathematics. I like to thank our Honorable Chairman, Dr. A.C. Shanmugam, and our beloved President, Thiru A.C.S. Arunkumar, for permitting us to conduct this FDP. On behalf of Dr. MGR Educational and Research Institute, first year BTech campus, it is a great pleasure for me to welcome all of you here in the third day of our FDP program, Multi-Dimensional Scaling from Science to Technology, in association with International Relations Office. I welcome Dr. S. Geeta Lakshmi, Vice Chancellor of our university, Dr. V. Civilraj, Joint Registrar, Academics and Administration, Dr. P.P. Debaraj, Joint Registrar, Indus, Dr. N.S. Subhashri, Dean Iendes, and Dr. Kaushalya, Coordinator, International Relations Office, to be with us today. We are fortunate to have an eminent speaker, Dr. N. Krishnakumar, founder, InstaGana, L.L.C, USA, to talk about applying artificial intelligence and machine learning techniques to multi-messenger astronomy. His passion and knowledge towards this artificial intelligence will make today's session very effective. We are honored to welcome you, sir, and I would like to extend our warm welcome to our participants who are all accessing this event via live video from our Dr. MGR Landsmart YouTube channel. Once again, I welcome you all. Thank you. Now over to Dr. Lata ma'am. Thank you, ma'am.
Thank you, Prita ma'am, for the nice welcome address. Let's all know about our renowned speaker and his credentials, for which we request Professor Aruna from Department of Mathematics to proceed. Ma'am, please.
Yes, ma'am. Am I audible?
Yeah, proceed.
Very good morning to all. I am R. Aruna from the Department of Mathematics. I am here to introduce our today's chief guest, Dr. Krishnakumar Narayanan, sir. He has 25 plus years of experience in software designing, development, and delivery in the areas of system software and solutions. And he got his UG degree in the field of applied sciences from Tyagaraja College of Engineering, Madurai, and his engineering degree from Indian Institute of Sciences, Bangalore. He obtained his doctorate from Louisiana University, USA, and he has 3 US patents, and he has published many articles in many reputed journals. He is not only a technological expert, but also a very good listener of music, very good singer, and has the ability to compose lyrics in Tamil also. Through music, he is helping many charity organizations. Words and time are not sufficient to express all his community activities. Once again, I feel very happy and privileged to introduce you, sir. I thank Dr. N.S. Subhashri ma'am for choosing me to introduce the chief guest. Once again, I thank you one and all. Thank you, Lata ma'am. Over to you.
Thank you, ma'am. Dear speaker, sir.
Yes.
I'm very happy to share that I am also alumni of Tyagaraja College.
Good to see you. Thank you. Good to hear that.
Yeah. Sir, it's really happy to see you at a new avenue to empower the faculty and teachers across institutions, because we have been seeing you inspiring students pre-COVID-19 and during the COVID-19 situation. And now we would like to extend the good relation with you even after the COVID-19 situation.
Certainly, ma'am.
Thank you, sir. With that, dear professors, all assembled here, let's catch up, keep up, and put up with the computer-based technology. Now, Dr. Krishnakumar, sir, it's your turn to take the dial. So
Very
please.
good. Thank you, Madam Lada. So is it okay if I share my screen?
Sir.
Just a moment. Is my screen visible? Okay. Am I audible?
Yes, sir, it's visible. Yes, sir, it's audible.
Very good. Thank you. First of all, I'd like to thank the entire department, Dr. MGR Engineering College, the Research Institute. Definitely thank Dean Madam, Aruna Madam, and Lata Madam, and Sona Madam, and all the professors who had given us an opportunity to present this wonderful interdisciplinary webinar. And so, first of all, I want to commend the college and the institute for offering this to the public, and especially to a lot of the teachers and the students who are interested in doing advanced research. So definitely interdisciplinary is the name of the game these days. when Madam approached us and talk about what type of topic we can present it in this webinar. We were just wondering, obviously the computer science and technology is definitely one of them, and what type of field that we want to apply these technologies to, whether it should be in mathematics or physics or chemistry. And so one thing that came to my mind was astronomy. And astronomy is really definitely near and dear to me. I was always fascinated with things out there in the space, the solar system and beyond, while I was in high school as well as in growing up. In fact, after I graduated from Tyagaraja Engineering College with Applied Sciences, I had two options: either to go continue my master's in physics in IIT Madras, or to take up engineering degree at Indian Institute of Science. I chose the latter, and then ended up being a degree in electrical engineering, and then into computer science. And then ever since, I've been in that field, doing most of the activities in the communication, telecommunications, and in the image recognition and other areas. If I had chosen the other path, which is Masters of Science or Physics in IIT Madras, I would have definitely chosen astronomy. And so when I was discussing with Madam, so this topic really came up, and then I started exploring and seeing what kind of advancement that are happening in the astronomy, and definitely there are a lot of exciting things that are happening, especially in a field called multi-messenger astronomy. It is a branch of astrophysics, which we'll cover in a minute. So we thought that we will put together a presentation that basically describes how to apply artificial intelligence and machine learning techniques to MMA. So this is the beginning of that topic. And interdisciplinary area is very popular. And I would say we are in a golden period, right? I think if you think about the advantages of computers and technology in any field, it is now booming. Many areas in science and medicine and social science, they're all getting benefited from the computers. And definitely, this is very appropriate for the research institute to bring out these type of topics and motivate and inspire faculty as well as teachers and the students to look into some of these areas. So the purpose of this webinar is not really solve any problem, but really to present the opportunity in terms of how to combine different fields of studies in computers and in astronomy, and how can we leverage the work that has been going on. So that is the motivation for this webinar. So the outline for our webinar, first we'll briefly take a look at the background of MMA, the multi-messenger astronomy, and of course on the artificial intelligence and machine learning technique as well. And then we'll briefly talk about the AI and ML methods. What are some of the commonly used learning methodologies that are used typically to solve real-life problems, whether it is in medicine or in other areas in the industry, and how they are being applied. And then we'll focus more on what are some of the motivation for applying these wonderful AI ML algorithms to MMA. What kind of problems are we trying to solve? And along the way, I will also introduce an institute called LIGO India. It is based in Pune, and they are basically doing a lot of work in the MMA area, especially on the LIGO part. So I'll cover some of that as we go into the problem statement and how we can address that. And once we find a problem, how are we going to train those models for solving that problem, and how are we going to verify them using simulated data first and then with real data. So those are some of the things that we will cover. Of course, like with anything else, before you do anything, you want to understand what is already out there. So we'll also cover some of the popular AI ML frameworks that the companies are building to the community, and most of them are open source software now. So you can take some of the pre-built models from those frameworks and apply them to any field, and then we'll take a look at how it is going to be applicable for MMA. And then we'll cover with some of the references and literature in both interesting fields, MMA and AI and ML. We'll then open it up for any question and answer. So that's kind of a brief outline. I would like to introduce both these fields and then see how they can aid each other in solving real-life problems. First, background on MMA. Okay, so on the networks. So multi-messenger astronomy is nothing but a branch of astronomy. It is primarily motivated to understand and coordinated observation and interpretation of disparate messenger signals. So what are messengers? Messengers are any objects that are out in the space, either within our solar system or beyond the solar system. And I mean, typically when we started astronomy in the olden days, a telescope was the only instrument or the major instrument that was available. People would use them using light. Whatever you can see is what you can observe and you can interpret. But over the period, number of instruments in the astronomy has gone up. We have very sophisticated instruments that can measure not only visible light, but also in the other form of electromagnetic radiation, as well as other types of signals that are coming in from the space. And so those are called messengers. So the objects that emit any type of these signals to the Earth are called messengers. And this is why we call multi-messenger astronomy, because the messenger could emit multiple type of signals. It need not be just one type, like an electromagnetic radiation. As they move, they could be generating waves. So this is one of the reasons why this field is so fascinating, where different types of data coming from the outer space, and how do you make sense out of that, and how do we understand and simulate and predict what could be happening in the future. So this area is getting a lot of interest in the astronomy, especially in the astrophysics field. It's a very active research topic. So I talked about the extrasolar messengers. They're coming from the objects beyond the solar system. There are at least 4 types of messengers. Electromagnetic radiation, we all know about them. Gravitational waves is something that it is like a ripple space-time type of wave that is observed. It is very sensitive, so you require laser interferometer instrument that you need to capture those waves and detect them. So you need very sophisticated instruments to do that. Of course, there are other type of messengers like neutrinos and cosmic rays. For example, in a solar flare, you would have probably heard in news that there is a solar flare that is approaching, and it could be disrupting your communication network or radio networks. So those are all some of the examples of events or astrophysical processes that receive these signals, whether it is in the form of radiation or in the form of cosmic rays or gravitational waves. So solar flares is an example. Supernova was another example that happened in 1980s, 87 to be precise, where there was a massive explosion and of stars, and it was a treat to astronomers in that time frame, where they were able to observe a number of signals coming into the Earth. And I would say that is the beginning of the MMA, when the astronomers realized that they can observe not only what is visible through the telescope. Of course, that still is still important, because there are several satellites carrying telescopes around the Earth, and they would be sending those signals. But in addition to that, there are astrophysical processes that are happening that can be detected. And once you detect them, then you have an opportunity to learn from them. And then, of course, there are many other astrophysical processes that are there in the literature. So the purpose of the MMA, if you think about it, is to detect these type of disparate signals. Some of them could be coming in from the same object. So how do you correlate that data that is coming in, and then how do you make sense out of that, and how do you learn from that, and then over a period of time, how do you simulate that? For example, how would a next supernova event would look like, or when would be the next solar flare that could happen? So both simulation and prediction is an important aspect of astrophysics, especially in the MMA community. And so as and when the number of events, the astrophysical events that grows up, as well as the data that is coming in from those objects increase, that's where the technology becomes important. And so in terms of computing power, processing power, as well as memory storage, and analyzing in real time and getting that information out to an astronomer is going to be very, very important. And I've noted some networks out there. S-News is one example, And so some of these networks are getting automated. What do I mean by that? They're already bringing in several of these computer algorithms to interpret them automatically. So they don't rely only on astronomers, human prediction, but also some computer-based prediction and simulation. So this is so just to think about this as the introduction to MMA, and I wanted to make sure that you have enough information and inspiration. And this field is definitely hot, and some of the literature that I will show in the future slides. In fact, as late as 6 months ago, there was an article in Forbes that said MMA is going to be the future of astrophysics, and because this has a lot of potential to learn more about all the galactic events and understand from them. And computers are going to play a major role. I think both in terms of the cloud computing, because of the data that is coming in from these objects are going to be enormous, and dealing with big data is going to be a challenge as well. But then the other aspect of what we would cover now is how do we apply the intelligence and the machine learning techniques that have been developed for different areas, and how do we bring them into MMA. So that's a quick background on the MMA itself. On AI, some of you might be thinking, oh, this is AI is fairly new. It's very hot, so it must be 10-year-old, 20-year-old. But on the contrary, it has been around since 1950s. In fact, the very first conference was held in Dartmouth. I would say that's the beginning of AI. And at that time, the community was trying to mimic human behavior and intelligence and bring them into the computers. And that was a very bold statement. Very tall order at the time of the year. Basically, the computers were just beginning to happen, right? Not many companies who were doing computers, and it was very, very early. So there were a lot of frustrations for the next 2 decades or so. People were basically thinking maybe we went too far in our ambition. Maybe it is not possible to mimic human behavior using computers, and that's why some of the funding got reduced. And there were a lot of frustration among the scientists. Then came in 80s, there was a transformation or a breakthrough in the form of what we call as expert systems. These are nothing but rule-based knowledge systems where you can input some of the a priori historical data, input and output. So the system would characterize them using a set of rules and then start predicting and interpreting anything that is given new. So coincidentally, my PhD thesis was on an interdisciplinary topic. So basically, it is based on an expert system to interpret oceanographic images. So I'll draw some parallel to how it is applicable to MMA. So in my thesis, it was mainly the satellite images of the ocean. In this case, it was an Atlantic Ocean in US. And so the satellites would send tons and tons of these high quality, high definition satellite imagery data, pictures of the ocean to the Department of Navy that was sponsoring my PhD at that time. And the idea was these pictures were manually interpreted by the oceanographers. So they would take a look at those pictures and identify basically oceanic currents and some of their characteristics in terms of where are they located, how are they spinning, what direction are they spinning, what is their velocity, what is their temperature. So a lot of the characteristics of the oceanic currents were relevant for Navy, mainly for the reason that this information should be transmitted to the vessel or a ship that is sailing in the ocean. So the captain of the ship can know when to avoid a particular current. If they go against a current, they would be spending a lot of money on the fuel, whereas if they go along with the current, they could save fuel as well. So it was a multi-billion-dollar project that was awarded to the Navy, and I was part of that to complete that the thesis. But the parallel is it was very similar. I mean, just like how MMA would require interpreting those signals, whether it is radiation or gravitational waves or cosmic rays. How are we going to interpret them and make sense out of those messenger signals? A very similar problem was given. In this case, it was satellites images that are coming in that needed to be interpreted. And I was also using a very old technology called expert systems. And expert systems were rule-based, but we all know our human brains don't work like a rule-based system. It is much more complex than that. But that was the beginning of resurgence of AI. And then since then, people have been building neural networks. I mean, the idea was to mimic from the brain research all the functions and the principle that we learn about how neurons work in our brain, how do they carry information, how do they act on a stimuli, how do they transmit the information to the other neurons. So all of that study in brain research was fed into the computer science. That's when the artificial neural networks started to come in. So they started modeling those neural networks based on that research. And then machine learning algorithms, which I'll cover in a bit, are nothing but computer algorithms that try to learn from the past experience. And deep learning is another buzzword. It is again how much knowledge you want to store in the neural network in order for you to interpret them correctly. So those are all part of that evolution. So basically, the idea behind this slide is to give you that AI and ML has been around, but we are living in a very fantastic period where the technology is a little bit more mature. And I think Madam talked about the Google Map and other things that are happening in the industry. We are using them every day, whether we know them or not, but they do show up. But interesting thing is now there are software packages and solutions available where you can use them to solve a particular area. In our case, it'll be MMA. So that's the background of AI and ML. A little bit more on the machine learning itself. It's a branch of AI in computer science, and it's a study of computer algorithms that allow programs to be automatically improved through experience. I think there are three types of learning: supervised, unsupervised, and reinforcement learning. I'll cover some of them in the future slides. I mean, Madam talked about Google Maps. I think I threw in a few other examples. Netflix is another example of an AI ML system with this COVID-19 situation, where a lot of the people who would otherwise gone to a movie would sit at home and watch movies through a live streaming service such as Netflix. And what they do is they use an AI ML system in the back end to understand the user behavior. You know, what type of movies are you watching? What is the frequency? What type of movies you like? So all that information get fed into an AI system that is used to make predictions as they go along. So that is so machine learning is definitely a part of that activity. Artificial intelligence itself is a much larger scope, and it is growing every day with a different type of neural network that is coming in. And basically, AI is nothing but application of these machine learning algorithms onto a specific problem. So when we say this is an AI network for MMA, what that means is we have taken some machine learning algorithms, apply them to solve an MMA problem, and that becomes the AI system for MMA. Just like there is an AI system for map and live streaming, there could be different types of AI systems. So AI is a very generic term, whereas the machine learning algorithms are specific to the computer algorithms that are powering those AI systems. I briefly talked about the machine learning techniques. So there are two types: supervised learning. I think here I given a very simple example of a supervised learning where you not only provide an object that you want the system to learn. So in this case, let's say we gave a bunch of animals, and not only you give them the picture, but you also label them, right? In this case, for example, we have labeled some of them as 2 ducks, and then the other one as not ducks. So basically, it's a very simple system that determines whether the given animal is a duck or a not duck. So you can imagine, you can draw the parallel from here to MMA, where if you get a gravitational wave signal and electromagnetic radiation from a particle from space, you can start labeling them. And during the training process in the model, this is what you would do during the training phase. You would take an existing, already interpreted data and start inputting that, both the signature of the wave or the signal that you received from the particle or the object from the space, and then you associate with a label. And then that's how typically the training of the model happens in a very structured way. So this means the model will understand that if it sees something very similar to that particular signature of the signal, then it will start comparing and start predicting that it looks something like a gravitational wave, and hence this needs to be a solar flare system or a supernova event. So those are the type of training model that you would go through in MMA. But coming back to this example, basically it basically allows the model to learn, and then when it predicts, it becomes a very simple proposition. You provide, for example, another bird that looks very similar to what has been learned. Then the predictive model, what it does is it goes through the pattern matching and the pattern recognition algorithms, and then understand that it is closer to the animal called the duck or a bird duck. So what they do is they go through what are known as a confidence factor. After the AI prediction is done, they would compute the confidence factor and determine that the highest matching label here is the bird. So we will do a similar exercise in MMA as well. So we'll say when a different signal or a brand new signal comes along, the model will iterate it through and then come up with the prediction and say, yeah, this is from a particle X, Y, and Z that I had seen before. So it's a very similar approach that is used in many of these fields. But the example that I gave here is a very simple one, so you can get an idea of how the supervised learning happens in terms of creating the model and then using them to predict. On the other hand, on the unsupervised learning, it's also called clustering algorithms. You don't specify any particular label, so you just randomly give those pictures and let the system learn by itself. And so the way they do that is by clustering them. And the disadvantage of this one is it's not going to be very accurate because you've not specifically done the learning in a structured way. And so obviously the results are not going to be great. So most of the systems that I see today in the AI field is all on the supervised learning scheme. So that's what I would say. Let's say if you were looking at and applying AI ML to an MMA, then I would strongly recommend taking a look at any supervised algorithm that is out there. So I think I'll cover some of the AI frameworks in the later slides. So when you go through them, one of the things that you want to look for is how accurate these models are for a similar problem. So you want to pick those models and the algorithms needed, and then apply them to MMA. The last type of learning is called reinforcement learning. So majority of our human brain, I mean, basically the way our brain understands and learns things is through reinforcement. Whether it is in the form of a child that is trying to learn in the early days of childhood, or any system that we are building. Typically, the way it works is you have an intelligent agent that is basically understanding the environment through some sort of state information. So, and then once it understands the environment, it takes an action, and it gets the feedback from the environment in the form of a reward. And then the agent basically factors that into the next action. So it basically understands that if I gave this action, this was a reward. It was a positive reward or a negative reward, or I need to adapt my next action appropriately. So the intelligent agents constantly learn from the environment, both from the state as well as the feedback that is direct result of the action. And then that's how they learn over a period of time. A classic example here is computer games. You all would have seen, chess games playing against humans. And what they do is the games would understand the environment, which is a player, and then start making a move, and then understand what the player's move was. That is nothing but a feedback coming back, and that's how it builds the intelligence over a period of time. And as the computer game plays with more and more players, it has all the knowledge in terms of how the humans react to those actions. So this is another example of how reinforcement learning works. So this is something that you may also want to take a look at when you apply the same algorithms to MMA. For example, let's say you built a model for MMA, and you are iterating it through. And if when it tries to interpret wrongly, then you want to feed that information back to the system, saying that no, I think you made a mistake here, and that's how the neural networks will adjust their parameters. I mean, neural networks, I think I'll cover that in a minute. They're all the statistical algorithms, Bayesian techniques that we've all learned in the statistics and the theoretical computer science. All of them are modeled into neural networks. So this is the third type of learning. And so let's go to the next slide. Just a few concepts and approaches. I think I already talked about intelligent agents. They can be software, hardware, systems, but their primary purpose is to correctly interpret external data. So in our case, for multi-messenger astronomy, the signals coming in from the extrasolar messengers need to be correctly interpreted. So, and then they learn from the data that they have interpreted. So use the learnings to specifically achieve some goals. So anytime you think about applying, always think about what is the intelligent agent that is going to do in my case. Whether in the case of Google Map or in the case of MMA, there is an agent, intelligent agent that is constantly understanding the environment, understand the input and what it has learned so far, and then try to apply in the action next time around. So artificial neural networks, like I already mentioned, they are inspired by how our brains work, how the neurons work in our brains. The simplistic way to look at it is there is a bunch of input neurons that act on stimuli. Stimuli is any input coming into you, whether it is our visual system or auditory system. So the inputs are coming in, and the equivalent analogy on any field is any signal coming in from MMA could be an input, and the hidden layers of the neurons that contains the knowledge. So our model that I talked about for MMA are nothing but hidden neurons or hidden networks that has that information. And so when the input neuron gives that information to hidden neurons, they work on it, and then they activate the output neurons, and that's what sends that action item to the external world. So modern AI systems, they all work on some variation of this ANN and provide programming framework for scientists and engineers. So in summary, I think AI basically consists of building those neural networks, and then how to constantly update them as we learn about the environment more and more. So it is not like a static program where you write once and then you forget about it. It is always a constant process of improving them through time, over time. Okay, so we have learned about MMA. We know that there is plenty of challenges in there, and then we also learned about AI ML. So how are we going to apply AI and ML to MMA? What is the motivation, right? So if you think about it, there's a huge amount of data. I think as we talked about, there is millions, if not billions, of astrophysics processes that are happening in the universe. And the data, like I said, it's no longer about a telescope. It is all about different instruments, sophisticated instruments collecting data. So there's huge amount of data that needs to be processed in real time. And that is definitely a challenge for the technology. And then sophisticated signal processing algorithms. As I mentioned, I think the gravitational waves are very sensitive. You need to have very specific interferometer, laser interferometer, to observe those waves. So the signals from those waves. So you need to have very good signal processing algorithms that can kind of linearly interpolate if there is any missing pattern in the signals. So the signal processing algorithms have to be a lot more sophisticated. That means there is more computing power and storage required for that problem to be solved. And typically in astronomy, especially in MMA, simulating, let's say a specific event, simulating the next solar flare or simulating the next supernova or any event you can think of is going to be an important aspect of the research, as well as predicting, right? Based upon all the conditions, when do you think the next thing would happen? So, of course, we're not there 100% in predicting all those galactic processes, but at least we are always trying to predict. So those are the three areas of interest that I can see where there is a need to apply AI/ML techniques to MMA. And the technologies involved, like I mentioned, big data is definitely one of them because there is a ton of data that needs to be analyzed. A large distributed computing system such as cloud, As you know, it is impossible to have a system in your lab to manipulate or interpret all these data in real time. You need to have a distributed computing system. Fortunately, we have cloud technology that can come into help. I think tomorrow Mr. Rajesh Kumar is going to talk about that, all the various cloud technology that are out there and how some of them can be applicable for MMA. But for today's topic, we will focus more on the AI and ML algorithms, and that technology can be used for simulating as well as for predicting. Interestingly, this work is already started, so it's not something new. I can send you some papers. Actually, in fact, later slides I have given some references to the current work. What people have done is they have constructed what is known as an MMA and pipeline. So the easiest way to visualize that is if you have taken 3D graphics course or research in that area, there are three-dimensional graphics pipelines that people build in graphic systems. So basically, you start with primitives, and then you start applying some geometrical algorithms or processes like rotation and magnification, spacing, and so on. And then you start applying shading algorithms, texturing algorithms. So it's like a series of operations that go in a pipeline. So MMA has already come up with a similar set of steps that are needed. Let's say if you get a series of signals from the objects, how do you put them through this pipeline? And at every one of the steps, what kind of analysis that one needs to do, that it has been processed, then you send it to the next phase, and so on. So there is a pipeline for MMA that has been already in works. So one way is to take that as an example and see how we can use that to simulate the next event, and then how do we apply our AI ML techniques to do that. So this requires massive computing, clearly, because of the amount of data that is involved and amount of number of events that happens in a day. That also is a big factor. Plus, you need things to be done in real time or near real time, because the astronomers could be waiting for that data. So because of all this, it's a very active research of applying AI ML to MMA. And one of the references, like I mentioned, it's a very interesting field where it is not only astronomers, but computer science people, mathematicians, as well as physicians, physicists who are doing work on the instruments. They all get together and find out what are the areas that we need to solve in this space. So I'll give you some examples of that in the future slides. Here is one, for example, LIGO India. LIGO stands for Linear Interferometer Gravitational Wave Observatory. It's a mouthful phrase, but basically what happened is after the supernova event in 1987 in Caltech and MIT in US, they formed an observatory. The purpose of that observatory is to detect, measure, and analyze gravitational waves coming from the particles. So that is done through the fine instrument called laser interferometer. And so this is a very sophisticated lab that is fully equipped with instruments as well as computing needs like grid computing and cloud computing systems. LIGO India is part of an inter-university center for astronomy and astrophysics. It is based in Pune, and they're doing some great work in the space. I think I've given a diagram in the slide. What they do is they kind of mix all these technologies, including your X-ray and other radiation-related fields, as well as the quantum theory and other related subject matter. Plus, they also have data centers and grid and cloud computing. So all of them come into pictures in their research lab. And of course, they work with the colleges and other institutions. So one area I can think of, if somebody is interested in doing some interdisciplinary research in combining AI and ML with MMA, universities or the institutes like the LIGO India could be a great place to start with, because they're already in the MMA space. They are dealing with those type of problems, and then I can clearly see an arm added here for AI ML, where we can bring in some of those newer algorithms to start simulating and start predicting those events. So please check out LIGO India. That's a great place to start as well. Here in the slide, I just throw in some high-level steps in terms of how do you go about and solving a problem. For example, if you're doing a master's thesis or a PhD thesis, half the time finding the problem itself is going to take a lot of time. But interestingly and fortunately, interdisciplinary areas are a little bit easier because there's plenty of problems to be solved, unlike the traditional fundamental sciences like physics and chemistry and biology, where it is hard to find a problem that has not yet been solved. So computer science is slightly better because the field is relatively new. And specifically for MMA, and especially if you're applying AI, ML to MMA, there's definitely a lot of potential to identify a problem. In this case, I identified MMA pipeline as one of the problems. But if you go through the literature, you can find different other types of problems that MMA poses to the astronomers. You can pick any problem that is relevant for AI and ML. So picking a specific problem is step number one. Then build and train models relevant to the solution. So what do I mean by that? You build a simulation model, for example, in this case, MMA pipeline. You can build a simulation model using an already pre-built model for some other field, whether it is facial recognition or document extraction, optical character recognition. There is a bunch of pre-built simulation models that are available. So you can take a look at them and then apply them or modify them for your MMA pipeline problem. And select a suitable modeling framework, AI modeling framework, which I'll cover in the next slide, where there are plenty of software help available. You can download, TensorFlow is an example from Google, where you can download and install any one of these pre-built machine learning models that you want to take. So you can take a representative model and then use them for your MMA pipeline problem. And then once you identify the model, then you train the model with the known data that you have collected over the period of months or years. Once the training is complete, then the next step would be to verify your model using simulated data. So that's the next step, to make sure that your model is working fine. And then finally, you verify the same models using real-time or real data coming from the messenger data. In this case, for example, if you collaborate with institutes like LIGO India, you could potentially get some real data from their observatory. And so you can use that real data to make sure that your models are working fine, both in terms of simulation as well as for prediction. So, like I said, in an hour we cannot solve any problem, but at least the motivation for this webinar is to expose you to some of the technologies as well as some potential opportunities to apply the technologies to an area such as MMA. And some of these high-level steps are something that people follow. Let's say if you are in a different field, let's say you are in a gene analysis field in a biochemistry field, it will be a very similar set of steps. Identify the problem, get the model, and then train the model, and then verify the model using simulated and then real data. So that's what I would recommend if you are interested in pursuing research in this topic. So, like I said before, 5-10 years ago, AI ML was relatively new. Not too much software modules were available, so you need to build everything from scratch. But now it is very different, right? I think we also talked about MMA requires large computing power, such as cloud, and the popular cloud providers are Google, Amazon, and Microsoft. And all of them have an AI ML framework. Google calls it TensorFlow, Amazon calls it SageMaker Neo, and Microsoft Cognitive Toolkit. But fundamentally, what they do is they try to abstract the learning algorithms, machine learning algorithms, so that you don't have to reinvent what they have done. And they make it easier for you to train the model and then use them for your application to start with. Clearly, all of them are getting used commercially, like Airbnb, eBay, and others. They use TensorFlow. They provide a bunch of tools and libraries. So if you're a MMA researcher or a computer science faculty or a student, master student, PhD student, who wants to develop an AI ML algorithm for MMA, then you can download these libraries and tools from Google. Pick any one of those pre-built models. Let's say they have used it for gene analysis or optical character recognition. Pick any one of them that is relevant and closer to your MMA problem. Then you can modify the models in such a way that it will be applicable for what you're trying to do. So Amazon has got a similar machine learning algorithm as well for developers, and they are also getting used quite heavily. Microsoft has a deep learning framework, and they call it BrainScript. They have a different programming language. They also internally use that for their own services like Bing and Skype. So I just thought I would give some introduction to some of the popular frameworks. Of course, there are many other AI/ML framework that one can take a look at. But for any researcher, in order to get started, you can start with one of these, and then as things go by, you can take a look at others as well. But one thing that I would always tell somebody who is looking for a PhD topic or a master's thesis topic, finding the problem and then spending as wide as possible to understand what problems are there would be the most important step. And then once you identify the problem, then you go deep and then try to understand all the characteristics of the problem, and then how to solve them in a number of ways. I mean, one example I can think of is the application of each one of these frameworks for an MMA problem itself could be a great PhD topic, because that is something that is not done. And in fact, some of the research article that I'm seeing on this field is relatively new. People are barely getting into it, and people are understanding that yes, different community people need to gather, like computer scientists, astronomers, and physicists need to come in and collaborate and do it. So this, I think the timing is good. That if somebody wants to get into this space, it's relatively new, and there are a lot of problems that can be solved. And the good news is the technology exists today, and so you don't have to start from scratch. There's plenty of things that you can start right now, and then as you go along, you can tweak it, and it's going to be a lot of fun and doing that. Okay, so that is I hope that gives you an idea of the two fascinating fields, AI, ML, and MMA, and where is a need for automation and interpretation. So in these two slides, what I've given is I've given some references to MMA. Of course, MMA Wikipedia itself. And here is a great article from Forbes where you'll get the inspiration and motivation that this just came out 6 months ago. They said why MMA is going to be the future of astrophysics. That's rightly done. I think that article is very well written. That'll give you a lot of motivation in terms of how the astronomy has grown over the periods from just pure telescopes to all kinds of instruments and systems that can detect very hard to find signals that are coming from the outer space. So I would definitely urge you to read this article. Of course, this is the paper I was talking about. This about 25 people got together and wrote this report. It's a deep learning for MMA. So it is basically identifying the problem and saying that yes, this is a problem that needs to be solved. Because it cannot be solved by a bunch of astronomers anymore, because the data is just too much to handle, and it's going to take a lot of time, and so they need the technology help, and the deep learning is something that they are looking at. So I just thought that is just one example. Of course, if you look around, if you're seriously getting into this field as a master's thesis topic or a PhD topic, then you will find a lot more literature where people are trying to apply these learning algorithms to MMA. Then I also, given the Lego India site, I would also strongly urge you to take a look at their activities as well, because they would have done already some work in applying the computer technology, not necessarily AI, but some of the grid computing and cloud computing technologies to MMA, or some part of the MMA they would have already applied. So you would also learn from that and then see what has been done and see if there is an opportunity to collaborate. And at the end of the day, this kind of problems can only be solved with collaboration among different institutions and companies. So those are all the references for MMA and AIML. Like I've given all the framework that I talked about from Google, Amazon, and Microsoft. They're all talked about here, and then some introduction to AI. And then, of course, there are lots of books and tutorials available on AIML. Definitely an hour is not enough to cover all of them. But the idea was is to kind of introduce you to these two topics and then create the motivation and inspiration. So if somebody wants to get into that field, there's plenty of things that can be done. And hopefully that will be more inspiring, and many more people would get into that field and contribute and make it more successful. I think that is it from my side. I think that was the last slide. So once again, I want to thank the Dr. MGR Engineering College and the Research Institute for giving me an opportunity to present this and share that information with all of you.
Thank you, Dr. Krishnakumar. Hi all, this is Dr. Preeta George on behalf of the organizing committee taking up the charge of the latest session of International Faculty Development Program. And there is a saying like this: a lamp does not speak, it introduces itself through its light. And your talk on artificial intelligence, machine learning, multi-messenger astronomy sheds the light of your contributions and passion towards it. I like to call this session as a big bang explosion of knowledge on the buzz terms like artificial intelligence, machine learning, and multi-messenger astronomy. And to walk through this maze of the academic life, one needs the light of wisdom and guidance. We are lucky to have our pillar of support, brain behind this International Faculty Development Program, our Dean, Dr. N.S. Shubhasri, among us. I request ma'am to grace this occasion with a few words. Ma'am, please.
Thank you, Dr. Preeta. Hope I'm audible.
Yes, ma'am.
Yeah. So, thank you all. Good morning to one and all present here, to all the participants. Good morning, Krishnakumar sir. I think that was yet another wonderful session from you.
Thank you.
Actually, I would like to brief the participants regarding our collaboration. So, sir is the founder of InstaGana Live, and through Ms. Aruna and Dr. Kritika, Dr. MGR University and InstaGana, we have entered into a MOU. Actually, this MOU was initiated only for giving project-based learning to the students, right, sir?
Correct,
but I think from today's session, I think we can also have a collaborative research. So you have opened a new avenue. Definitely, as a physicist, I'm very, very excited to know what are the opportunities and how we can work together. So I think today's session is very, very brilliant, and thank you, sir. Thank you for it. So before just leaving, I would like to just leave a message to the participants. Now, many of you are wondering, seeing our topics and the FDP are conducting. So generally, during this COVID time, we have seen only webinars and FDPs on how to do learning, virtual learning or virtual teaching, all those things, right? So when we thought of putting a FDP, we thought that it should be something different. And once having all the good eminent personality roped in, then only we were in the situation of framing the topic for FDP. I think the topic and the speakers are aptly joined together. That is my view. I would like to share my view here. So this is really a multi-dimensional approach. We have given a multi-dimensional approach. It's not a single way we have shown to all the faculty. It's a multi-dimensional approach. And I think the topics covered and the speakers are excellently doing well. So I request the participants to take home all these messages and work on any particular dimension in which they want to do. I would like to brief the speaker. Yesterday, we had a mentoring session, how the faculty can mentor students in research, entrepreneurship, and various skills. And in the first day, we had the collaborative research. What are all the opportunities we have in the collaborative research? So today you have shown a different dimension. So I think it is really a very good program. Hats off to the team that is working behind. And once again, I thank Krishnakumar sir for your support. And I think we have to look into many such avenues
Yes.
for even the staff to have a collaborative research. So thank you one and all present here. And thank you for the opportunity. And it's really a wonderful job by the team, first year BTech team, even though I am leading, but it is my team who are doing it, sir. I'm very proud of my team. Hats off to you, team. Thank you, one and all.
Thank you, ma'am. Sir, you can see the questionnaire session live chats brimming with many questions. And I like to address the first question. Can we proceed for that, sir?
Yeah, please go ahead.
Yeah. The first question is raised by the Swapna. What is the difference between artificial intelligence and machine learning?
Oh, very good. That's a very good question. So machine learning is a subset of artificial intelligence. It's a branch of artificial intelligence. Artificial intelligence is a very broad scope. It is a concept, whereas machine learning is a bunch of algorithms, a study of algorithms. So the best way to say it is machine learning is a subset of AI. So AI over a period has been covering all the way from expert systems to what it exists today. But machine learning are specific to developing those algorithms that are required, like the supervised learning, the unsupervised learning. So all of those techniques are collectively called machine learning algorithms, and that field is a subset of AI.
Okay, sir, the next question is how can we integrate artificial intelligence in education?
Oh, another fantastic question again. So one of the things that we have been exploring at IGL is education. Because of this COVID-19 situation, everything is now turned around in education, right? I mean, all the in-person education is now becoming online, virtual classrooms. And then how do we enable the teachers? I mean, teachers, a lot of the times they hear about the frontline workers in hospitals, they're doing great. But I think teachers needs a lot more credit because overnight they've been asked to change their way of teaching to something totally entirely different, to an audience that is not used to this type of learning, right? So hats off to your college as well as to many institutions who are trying to adapt to it, and they're still learning with it. So one of the things that we are trying to understand or trying to help from our side is how can we have, let's say, an intelligent chatbot, right? One of the areas of artificial intelligence that is very popular is chatbots. Chatbots are nothing but software robots that it can be your personal assistant. So just think of a classroom assistant for a teacher or a student that can monitor all the students' progress as well as in terms of how they're doing in terms of their coursework, assignment work, their reading material, all the things, and then report that back to the teacher. And then so you can think of a virtual classroom assistant in the form of an AI. And then it can learn over a period of time, right? For example, if you know that the particular student needs some help in mathematics or needs some help in physics, so it can understand that environment of the student and then predict or suggest some additional reading materials. So there's plenty of problems in current day education that can be addressed through AI and ML. I just gave some examples.
Yes, sir. As you had truly said, the COVID-19 have changed the many lives. Especially, I would like to tell the life of the teachers. And we need some assistance. And through the artificial intelligence, I think by after the COVID-19, we will be able to do some wonders in the classroom.
Definitely. That is my hope as well, madam. I think you said, I think this is an area that needs a lot of help. I think our team is right now working on some aspect of it. So hopefully we'll share some information soon. Thank you.
Okay, sir. The next question is from Sudhaman.
Sure.
What is the accurate rate of prediction using artificial intelligence and machine learning algorithms?
Yeah, so the accuracy of prediction, it depends on I think we talked about supervisory learning and unsupervised learning and reinforcement learning. So the accuracy really depends on the model that you picked and how you train the model, right? It is it's very similar to you're teaching a child, and how far you have taught the child and the knowledge that has gone in will really depend on, I mean, the accuracy of their output will depend on what they learned, right? So it's very similar. So that's why it is important to pick the right model, the training model, and make sure that you chose the right algorithms to train, and those two will determine the accuracy of the prediction. And of course, if it is an unsupervised learning, the accuracy is going to be very low. If it is supervised learning, the accuracy is very good. One example I can give: facial recognition. You can clearly see the accuracy is very high, right? You go to Facebook, they can recognize your face instantly, and all of that is done through ML. And that technology and the algorithm has been they've been working on it. They've matured, so definitely the accuracy is really very high. Whereas if you go to different part of the different field in science, the accuracy may not be the same. So what I would say is, any area that requires more accuracy, or the accuracy is not enough, that means there is more work to be done in training the model and verifying the model and coming up with a better model, so the accuracy is better. So there is always a trade-off between how much training you can do and then how accurate your prediction is going to be. So depending upon your particular problem that you're trying to solve, you need to strike the balance between the two.
Yes, sir. Our next question is from Jayanathan. How artificial intelligence works in healthcare, especially in COVID-19 situation?
Right. So one area, I don't know if you have noticed, Google and Apple, they've released a contact tracing API. So basically, it can determine in your neighborhood anybody has COVID-19 infection or not. So basically, they have opened it up to the public. So all that information needs to come to a hospital, right? Basically, they need to have all the information about the so-called contact tracing. Who has that infection, who are the surrounding people. All of that information needs to be fed into a system that can understand and capture that knowledge. And then if it has a history of, let's say, in the last 3 months, this has been the trend in a particular area, how do you predict that for the next 3 months in that particular area? So there's definitely machine learning algorithm that can be applied for contact tracing area in COVID-19. I can clearly see definitely more systems coming in with the different models and start applying them in the hospitals and the healthcare, health ministries and stuff like that. You will see more and more AI ML based systems coming in and helping there.
And I think the Arogya Setu app is something like that, no?
Absolutely. Exactly, madam. I think that's the beginning of it. I think right now it is collecting data. So right now, what will happen is the backend system will start gathering the data, start creating models around it, and then they'll start predicting it, or they'll start creating simulated work. I think all of that will be happening in the background. So eventually, when the app becomes more intelligent, then it can start giving a little bit more services to the community.
That's society. Yeah,
society. Correct.
Sir, the next question is from Padma Sri. Differentiate between machine learning and data science.
Machine learning and data science. Machine learning is an algorithm. Data science is a field, right? It's a field in terms of how you would interpret data in what you have collected. So applying the scientific methodologies to data is what that is. So I think. Though it might look very similar, but one is algorithm based, the other one is more of it's an analytical field. I would say that will be the difference. Yeah.
And then the last question, I think so. How is soft computing related to artificial intelligence by Jacqueline?
Yeah, soft computing. I think it's somewhat related. I think one area where I could think of is you keep the input and output relationship in a computing a little bit flexible. So in that sense, your output is not going to be purely dependent on what you programmed it for. So they are somewhat similar, but I think the AI is, like I said, it is much more broader than soft computing.
I hope all the questions have been clearly well explained by our resource person, Dr. Krishnakumar. And I like to thank Krishnakumar, and I like to tell that this was a very interactive session, and the live comments shows that your session was very interacting and fascinating to all of us.
Thank you, madam.
Artificial intelligence is all around us and plays an inevitable role in our daily lives. To a layman understanding, it makes our life easy. Connecting with the friends through emails, from just playing computers to self-driving cars and parking vehicles, digital assistants, and much more. Artificial intelligence and machine learning was once a fanciful concept from the science fiction, but now a daily reality. In the prevailing situation of COVID 19, the greatest contribution from this field, which has become a boon to many lives, is Netflix. And with this note, I like to call upon Dr. Kalisuri from the Department of Mathematics to propose the vote of thanks. Gratitude is the memory of the heart. And with this, over to Dr. Kalisuri.
Can you hear me, ma'am?
Yes,
Can you
ma'am.
hear me?
Yes, ma'am.
Good morning, all. I am Dr. K. Kalishwari, Assistant Professor from Mathematics Department. It is a great privilege to propose vote of thanks on this special day on behalf of Dr. MGR Education and Research Institute, first year BTech campus. I wish to express my sincere thanks to our Honorable President, Sri ACS Arun Kumar, and our Vice Chancellor, Dr. Geeta Lashmi Mera. I wish to thank Dr. V. Cyril Raj, Joint Registrar for Academic and Administration, and Dr. Kaushalya, Coordinator, International Relation Office for the support. I wish to thank Dr. D.B. Jabaraj, Joint Registrar E&S, and Dr. N.S. Subhashri, Dean E&S for the continuous motivation and support for all the events. I wish to thank our resource person, Dr. N.S. Krishnakumar sir, for spending his valuable time on this occasion. His speech about applying artificial intelligence and machine learning technique to multi-messenger astronomy. The way in which he explained was very excellent, and he answered all the questions which were raised by the participants. I extend my special thanks to all those organizing staff members and all delegates to participate for making the event a very successful one. So once again, thank you all. Over to Preeta ma'am.
Thank you, ma'am. Participants, your attention. Kindly fill the attendance link which is provided in the live comments. And stay tuned with us for our fourth session on International Faculty Development Program on multidimensional scaling from science to technology tomorrow sharp at 10 a.m. Stay home, stay safe, happy learning. And it's thank you.
Thank you, madam.